All right, this is from section, we already said 8.1. The first thing you need to do is take care of the first sentence. Z varies, z equals, jointly with x and y. So the k is always there, that's your constant. Jointly means it's joined side by side with multiplication with x and y. That's the first thing you have to do right. Okay? Then it says to write a relationship for z, x, and y when these three variables are given here. So I'm going to plug in those variables. Z is 12, k I don't know yet, x is 8, y is 6. Okay? Well, I know that 8 times 6 is 48. And to remove that from that side, I'm going to divide that to both sides. So divide 48. 12 divided by 48 reduces to 1/4. So that is my constant. That's the first thing you have to find is your k value. Now, the second, that is the statement we need to answer, is write a relationship. So I can now do that. Okay, I'm going to plug that k into my original equation here. And that is the answer to that first thing that I wanted. Now, once you do that, if that's correct, it says then find z when x is -4 and y is 5. Once you do that, that's your final answer. Once you simplify it, you can do it with a calculator, but I know that 1/4 and 4 cancel. I've got 1 times a -5, which is -5. For this one, x and y vary inversely. This is one of the ones where you can have the x and the y in either spot you want to. I just typically like to have the y solved for if I can. But either one of these two ways, you can have x equals k over y, or you can have y equals k over x. Raise your hand if you did it this way, so I can see. Raise your hand if you did it that way. All right, good. That's the way I want to do it anyway. So, all right, so you'll get the same answer if you did it that way. It just takes a little bit more work, actually. But that's my equation. That's the first sentence. Then it says x is -4 and y is -5/4. So let's go ahead and set that up. And when you multiply -4 over to solve, -4, this -4 cancels. So you wind up getting k equals 5. Everybody get that all right? All right, so from there, now we can write the relationship. Just take that 5 and plug it in for this k, and you get 5 over x. Okay, that's the first part. Once you do that, the last statement's always easy. Then find y when x is 3. Well, just plug 3 in for x, and that's your answer. Did you? All right, for these questions, I want to use a model that best fits this data. And what I usually do is I look at the y values, and I can see very easily that my y values are going up until I get to around 53, 52, and then they start going back down again. So if you were to plot these points, not that this is where they would be, it would have this type of shape to it, which is a quadratic. Okay? So when you type these into your stat, remember you go to stat, go to edit, type your x values in list 1, type your y values in list 2, and then when you're done with that, you're going to hit stat again, go over to calculate, and because we figured out that it was a quadratic regression by the points, we're going to go down to quad reg, hit enter, and then you hit enter until you get down to store equation. And you always want to store this into your y1. When you get that, you hit alpha, trace, y1, so just hit enter. Hit enter until you get to calculate, and then hit enter again. And you'll get this that pops up. And this is what's going to tell you how to write the equation. Okay, the formula is ax squared plus bx plus c. Did you not get that? Did you do quad or lim? Alright, so this is what the calculator gives me. Y equals ax squared plus bx plus c. My a is -0.017. And that's going to be followed by an x squared. And then plus b, my b is positive, so it's plus 1.536, followed by an x. And then my c is a positive 18.071. That is my equation. Okay. Now, we stored this into my y equals. So if you hit y equals now, that equation is there. Okay. They don't round the decimals, but it's there. And I want to figure out what's going on at x equals 160. So I'm going to go to my table of values, hit second graph, and I'm not going to scroll all the way to 160. So to find where 160 is, you hit second window, have your table start at 160. And when you do that, you will roughly be at negative 175.1. That is your y value. All right, for this problem, you got to be careful with this one actually, because if you notice, my x values aren't really increasing consistently. It's going like 2 to 10 is by 8, 10 to 14 by 4, but it's kind of increasing at a steady rate. It's just not the exact same each time. But look at your y values. We start off decreasing by a little bit less than 10, and then about 6 we decrease by, and then kind of 7 there. Then it starts to decrease slower and slower, like 5.6 to 4.3 is only decreasing by 1.3 units. And 4.3 to 2.4 is also less. So it's increasing kind of fast at first and it's slowing down. What regression does that kind of remind you of? Exponential. Okay? Now linear would be, they would be decreasing steady, like decrease by 10 here, decrease by another 10, another 10. And it could be off by a couple points, like decrease by 9, then 8, then 10, then 8, then 9. If it's increasing consistently, that's linear. But this evidently is not. So once you get this typed into your stat, hit stat again, go over to calculate, and we're going to find the exponential regression, which is located down there at the 10th spot. Hit enter. Hit enter until you get down to store equation. We're going to do the same thing. Alpha, trace, y1. And then hit enter on calculate, and it's going to give you this. Now, it's giving you a different equation, because exponential is a times b raised to the x power. So your a is 48.899 if you round it, times, and then your b is 0.967 if you round it, raised to the x power. That is your equation. And now that's actually already in your y equals. Okay? If you go there, that 48 point whatever, and then times 0.96 whatever, raised to the x. If you have a hard time writing the equation, it's there in your y equals. Now let's predict what's going to happen at 120. Okay, so what will y be if x is 120? Now we know it's going to be less than 2.4 because my graph is slowly decreasing. So go to your table of values. Mine's at 160. I don't want to scroll to 120. So second window, 120. Second graph. And it's 0.85136. So 0.851. And guys, if you notice, it's got that exponential shape to it. It's decreasing, and it starts to decrease slower and slower and slower. And it looks to me like it's slowly approaching 0, but it's kind of hard to tell.